Question. A little bit easier one. Which of the following? You can see option A says that iron when reacts with HNO3. You should know the reactions of what you call HNO3. You must study that thoroughly. NO2 and water. Then B also gives rise to similar products. You should know that zinc when dissolved in NaOH, you can see that you will be getting sodium zincate along with that hydrogen gas. You must know that zinc is getting oxidized, so something must be reduced. So hydrogen gets reduced to 0. This is how we can make sure that hydrogen gas is evolved in this process. So zinc with NaOH is the right answer. And what about the option D? You can see that gold is reacting with sodium cyanide in presence of air, that is O2 and H2O, to give you what? NaAuCN taken twice, isn't it? So you can see that gold got oxidized from 0 to +1, and anyways oxygen gets reduced, so it will be forming what you call water, or it will be forming cyanide is involved. Water, I don't think so that we require to produce here water. Yes, if you write water also, it doesn't make any difference. Aqueous solution, yes, it is aqueous solution, so you need to write water here. So the product obtained is NaOH. So you can see that here how to make sure that you got hydrogen gas or not. You can see that gold got oxidized and oxygen got reduced. That's all, right? There is no point that hydrogen will be reduced from water, right? There is no point that you will be getting H2 gas over here. So you can see that there is only one option which is matching to this question, that is option C. Alright. So there is a method which I repeatedly refer to these type of questions. So when you take TeBr6 minus 2, you have to find out the n/2 value of the central atom, tellurium. Valence electrons, you know that oxygen, sulfur, selenium, tellurium, polonium, 6th group plus halogens attached, minus of minus, charge by 2. So this is the easiest way to find out the number of lone pairs. You can see that 14/2, that is 7. After that you have to subtract the number of atoms that are attached to it so that you can get the lone pairs. Do that in all the cases, isn't it? Br F2 plus. So you have to find out the n/2 of the central atom. Central atom is bromine. Valence electrons of bromine, 7th group, plus 2 halogens are attached, minus of charge by 2. So this is turning out to be 8/2, that is 4, minus, you must see how many atoms are attached to it. Like you have subtracted 6 from here, so you have to see how many atoms are attached, that is 2 atoms are attached, that means lone pairs are 2 here. Next you can take the next example, that is I will take the last one, because with this formula you can find out the last one but not the middle one. So you can take n/2 of the xenon. Valence electrons of xenon are 8th group, plus halogens are 3, minus of minus, plus 1/2. So this is turning out to be 12/2, that is 6, minus 3 atoms are attached. You can see 3 atoms are attached over here. So 3 lone pairs are obtained, and finally when you want to sum it up, you can see that you have got one more substance left whose structure need to be known, right? NF3. Alright, and nitrogen has a lone pair which had been donated to the empty orbitals of the sulfur, because that sulfur has 6 electrons in the valence shell. So there is no lone pair left on nitrogen in the third compound. Alright, so 3 plus 2, that is 5 plus 1, 6 is the total number of electrons all put together. Okay. Very important technique. I have released one video on this also, right? 1 minute short video, please follow it. Now you see the reaction of lead nitrate with NaCl gives rise to double displacement reaction. You know that PbCl2 is soluble in hot water, right? That means it is insoluble in cold water. However, when you are adding excess of HCl, you will be getting H2 PbCl4. So this is what is making it soluble. So right answer for this question will be option See, this is regularly asked question.